Well, hello again from Skip Victor Echo 6 Bravo Golf Tango. Another project. Got a lot of old parts laying around here, and I've been wanting to build something up for 23 centimeters to use just terrestrially. Something that's laying there ready to go sort of thing. So this is the story. So this whole idea started when a good friend of mine gave me this 23 centimeter amp, one of the W6 PQL designs. I had to finish putting it together, and then I built it up into a chassis to, fire it up to see if it was going to work okay. I put this chassis together and hooked it up to things and fired it up, and I was getting a good, well over 100 watts on this thing when I was running it at 28 volts, and mounted a cooling fan on the bottom, and it looked like a promising project. One thing I had to fix on these amps though was the input tuning capacitor. The little, little trimmer they had, and it was a terrible thing, and one actually failed. I mean, you think of all these spares I had in this little bin, you think I'd find something in there that would work, wouldn't you? What I wound up using was taking some of these real small air variables I had and cutting them down until I got first just a 3-plate tuning capacitor, and then finally down to a 2-plate. And these worked really quite well. I thought of ordering something in, but I figured, this works. This is just kind of a wild goose chase kind of a project. Anyways, I didn't know how it was going to pan out, so it was good enough. So I figured since I have this nice little amplifier, I better do something with it. So this is the plan. I have a loop yagi up in the tower already, and I want to put a preamp up there, but I don't want to have to worry about having, switching relays up top for high power and stuff like this. So my idea is to have 2 loop yagis up there. I've got one built already, another one's in pieces still. So that's why I wanted to use a transverter and an amplifier down below, and have 2 separate lines going up there. And then I have a preamp on one antenna for receive, and the other transmit antenna be by itself. Have an isolation relay up there, just like we do on Moonbound's operation. So I have this old circuit board type of transverter I used years ago. I actually used this for EME to begin with, an AO40, and it seemed to work okay, but now that I have some test gear for these frequencies, I hooked it up to a spectrum analyzer, and oh man, I didn't like what I saw, so I had to figure out something else. So I put out a holler to a few friends, and Grant VE6TA came up with this old SSB electronics transverter he used many, many years ago. And it's a good old thing. I had to do some work on it to get it going. It drifts a little bit here and there, but it's good enough for now to start with. If this whole project doesn't pan out, or I want to really make it a lot better, maybe I'll buy something new later on. But for now, this is good enough. So I wanted to get some of this stuff all put together and see how it was going to work. Right now, I've just been using the amplifier with the TS2000, but I knew the transverter was going to need a driver module. So I had this old chassis. I had to weld in a plate in the bottom, and I drilled a hole, or cut a hole in that for the fan. The amplifier by itself is going to be too tall, so I had to shrink it down in size a little bit. So with the amplifier mounted in there, I wanted to use this RF coupler to measure the RF output for the PIC display later on. And so I tried this right angle thing. It seemed like a good idea at the time, but later on I found out that it doesn't like all these right angle couplers. So you'll see later how it's just hanging straight out the back. Next was the driver module. This is a 4 to 6 watt amplifier that again comes out of an old scrap piece of junk I had laying around. I've used these modules in all sorts of things. In fact, I use it in my Moonbound's transverter setup. Anyways, I mounted a 1/4-inch plate on end to use as a heatsink, and then this amplifier module just mounts right on the side of it and keeps it cool if it even needs it. I don't think it warms up anyways. Then finally the transverter itself. I had it up higher on a set of standoffs. I knew I was going to run out of room here, so relays and other things are going to mount underneath this transverter, so the standoffs keep it up there. Plus it helps the semi-rigid line to come off the transverter directly into that 4-watt module. And then the output module, I put a piece of, again, semi-rigid line over into the input of the 100-watt amplifier. You can see at the very back where the the RF coupler is hanging straight out now. And this isn't the last of that. It changes again later. So I got into testing it, and I looked up to the Kenwood, and it worked pretty good. The signal coming out was 100% compared to what that other old ugly transverter I had was doing. But I found out that the drive from the transverter to that module, that driver module, had to be attenuated. So I put I think it was a 6 dB in there. I'll have to look at that a little closer. But anyways, it knocked the level down so it'd be a little easier to control. So things were looking pretty good. I was quite happy with the way it was performing. So I built up a backplate and got the RF connectors coming and going on that backplate, and some fuse holders, and got it piped into the transverter itself with some semi-rigid. So all left now is the I guess we'll call it a control circuit. The RF stage part of it works good, so of course more PICs. Since this unit's going to more or less operate just like any EME setup would, with separate antennas like this, so a sequencer is needed. And this is the little board I built up. It's very similar to all the other ones, and this video here is showing how I tested it. The bottom row of LEDs on the perf board there, test board, are the indicators on the front panel, the two colored LEDs, bicolor LEDs. And then the ones on the top are the actual sequencer activation LEDs, representing the relays running that part of the circuitry. The other two wires are disable inputs, so that if something is not right in the circuitry somewhere else, the sequencer will not activate. So I'm testing that next. With it disabled, it will not go into transmit, so it just sits there. With the disabled connection now disconnected, it will go into transmit, so everything looks good. But now if I'm transmitting and one of the disabled LEDs is connected, it will immediately switch over to receive real fast. Even with the push-to-talk line being held low, it will stay and receive until the push-to-talk line is disconnected or goes high and then back to low again. It'll activate everything the way it's supposed to. So that's it. That's all there is. The dual PIC monitoring board is a little more intense for checking out. You see it here. It's flipped upside down, the one board on top, so I can see the, I guess we'll call it the serial in from the Nextion screen, just to see what the LEDs are doing as I change pages and activate things on the Nextion, for just for checking. I like to watch the serial data as I change pages. If the PIC is sending serial data up to the screen of the Nextion and it's not on the right page, it will throw error codes and lock everything up. So I like to see how it's being handled that way. Here I'm going to the different set point pages and just make sure the numbers are scrolling up and down. If they don't, then I know the PIC isn't getting data back to the Nextion. So it's just one more thing to check. So this next part is something new I'm trying. This is the intelligent model of the Nextion screens, and it gives you a real nice icon, or whatever we want to call it, to use as a meter. And I'm going to try and use it as an RF output meter. Right now I'm just using a variable power supply as a signal going into it, and it being varied up and down is what's making the needle move back and forth. So we'll see. It's kind of a finicky piece of code for this part of it. Kind of jumped right into this video. Anyways, this next step is I'm going to check and calibrate the two current sensors I have for the power amplifier. I have the two separate leads that go up to the power amplifier tied together, so I'm going to be pulling current through both of them at the same time. So we'll see individual currents on the Nextion, but in the DC load circuit and the ammeter, it will be a combined total current. You can see where I marked with a felt pin on the board there, a 1 and a 0. That's where the current sensors are tied into the PIC through a couple of 1K resistors. So once again, using one camera for two different views, it's hard to keep it synchronized, but you get the idea. The voltmeter is combined, and the Nextion screen is showing the two individual currents, so they sort of add up together. You know what I mean. This next part is for the little circuit boards that hold the square LEDs for the sequence status indications. You can see in a little bin there I got quite a few of these. They're all surplus also. Here's a little ditty on how they check out. I put 12 volts to them, and then there's we'll call a signaling line, which I have to put 12 volts to, and it changes it from red to green and back and forth. So it's one way of doing it. Get the lights turned off here, you can see them a lot better. Oh, I'm such a cheap thrill seeker. Okay, that's enough playing around. So all the boards are done, and we can start laying things in the chassis and see how they're all going to mount up and start putting things together. So I got them all bolted together with the proper standoffs and everything put together. We'll figure out where we're going to put them now in the chassis and get things bolted up, hopefully. Maybe we'll get this thing finished one of these days. I knew I was going to have enough room, so this is why I had the transverter elevated. You can just see slightly underneath it there where the relay board is for the sequencer and some of the other control circuitry. The other two main PIC boards are just going to bolt in front. So that's all figured out. I guess the next step now was to take it apart one more time and build the face, the front end faceplate for it. So I was back out to the shop, cut out a piece of aluminum I had laying around, some more scrap, and made it kind of an oddball size just so it'll fit into the rack better and match up with everything, and of course rack handles. And again, there's more metal work. Get the jigsaw out, cut out a hole for the Nextion screen, which I had to build a special bezel again for it to mount in there, and so that fit. And then next thing was just cutting all those little square holes for all the square LED indicators. Yeah, square LEDs, I don't know why I use them. I guess probably because I got so many of them. Finally, start assembling things. Get some of the relays mounted, a couple of small voltage regulators in the center of the fan. Then the PIC boards where they were going to all sit in the relay board, and a little aluminum bracket for the current sensors. Then start putting the wiring on it, and that really turns into a nightmare. There's no real easy or neat way to do that part of the wiring. Got to have it in a way that the boards can be flipped upside down in case I got to fix something or change something a little later on here when we start proving out the circuit. So one thing about it, when the boards are iced up, you just tuck the ugly mess of wires underneath them and hope they don't pop out. That's one way of skinning a cat. Then with all the wires hooked up and tucked away, I put some 12 volts to it, and again, check out all the circuits, make sure the Nextion's working with the PIC boards and the relays are clicking and clacking and so on and so on. So it's all fun. Guess what? Take it apart again. Well, only the front panel this time. So took it back to the shop, cleaned it up, and got it ready for paint. Took the bezel off the Nextion, sanded it down, and gave it a nice coat of one of my favorite colors, a darker gray paint. And, makes it look a nice contrast. Then took the faceplate itself, sanded down the black color that was already on there, and gave it a coating of primer. Let it dry a little bit, and then give it a coat of clear lacquer to give it that nice light gray color tint. Then I printed out on ordinary paper the deckling I kind of wanted to use and position to make sure I liked the font and the size, just to make sure I'm happy with it all. And with a few sheets of decal paper I have left, I printed off the actual deckling and applied it to the clean panel, dried it off a little bit, and then sprayed it again with a nice clear coat of lacquer. So finally, it's all done. Mounted all the RF parts into it, hooked up all the cables to the amplifier and to the transverter and the driver module and whatever else. And she's looking good. She's all ready to go. So next step is just a little bit more testing, and then we'll fire it up and see what she does. So I got to it. I did have some smoke. Nothing serious, though. Actually, with smoke, just a bad smell. The RF coupler I was using in the back couldn't handle the power. This is the RF coupler I was using, directional coupler, and you can see the one probe casing on top there. This is what fried inside. You can see the picture here, the two holes, and there's a small resistor in there and a diode. Well, I guess there's just too much RF. I know it's like a 68 ohm resistor. It's kind of strange. Anyways, it fried, and I was really amazed how bad it smelled for such a small part. But no worries, I have a few of these, so again, more spare junk. So I went through all the junk and I found a different type of pickup. The probe's the same, or the pickup's the same, but the probe part is different. And I took it apart and had a look inside, and oh, this is really quite interesting. And look inside, there's an actual microwave diode. So it looked like the answer. I had to rewire it a bit, but it's on the back of it, and it was the answer. So with no further delay, here's the setup. The Kenwood TS2000 is fed out through the watt meter, just in case, into the back of the transverter on the new assembly. Then, like a lot of other things I've been testing, the output goes through the big Narda 20 dB 150 watt attenuator, into the RF sensor probe, and into the HP watt meter for final measurement. So we'll fire it up, throw the 12 volt switch, and have things boot up. When the sequencer PIC boots up, it takes the square 2-color LEDs and flashes them in a routine just as something pretty. The 24 volt DC switch isn't being used at this time. It's to turn on an external power supply later. A closer look at the Nextion screen when I flip the power on. Here you can see the sequencer lights being alternated from red to green in the PIC boot up. A lot better in the dark. There, it's all done. It's boot up sequence, and all the green lights are green, except for the one on the far left. That's the sequencer enable light, and it's flashing red because something's wrong. Get off the splash screen to the operating screen, and sure enough, bad 24 volts because I haven't turned it on yet. It's done with the power supply on the bench. Got the power supply turned on. Well, you got a good 24 volts now, so everything's good to go, all green. So I hope this doesn't get too boring. It's same as before in all my other videos. I'll go over to the set points and check all that out. Fan turns on and off manually, so that part's good. Check the set point for the automatic fan to turn on and adjust it accordingly. A little different from before. I usually have a fan on and a fan off, but the fan off is, I think it's down 2 degrees from the fan on, and it'll do it automatically. So 2 set points adjusted, I'll save it to the EEPROM, and it'll hold it there until next time. So next is the new feature that I've tried here for the first time with this intelligent series of Nextion displays, the RF meter. I have 2 different displays. One's for the RF coupler, and the other one is being calculated by the actual current drop being pulled by the amplifier itself. I did run into an issue here. The RF coupler output is not linear whatsoever. Not even close, and the Nextion needle movement on this meter is, processed or told where to go by degrees of angle. So in this case, this is from 0 to 180 degrees, so it was a real nightmare trying to get it to do something. So it was just easier to redraw the back picture of it in numbers in a nonlinear fashion. The amplifier current meter was a lot closer to being linear, so I put both in there. It's a relative indication. So I switch back through the 2 watt meters back to the main page, and flip over to this. This is kind of a different feature. I've usually do this by toggle switches on the all the other equipment I've had for moon bouncing and all this, and I figured I'd try this on the touchscreen. I control the preamp power on and off here, and the isolation relay power on and off, and I have to be in manual mode for them to actually take action. You'll see them change color, but the texting doesn't change from on to off, so it's a kind of a safe feature that way. And if I leave it in manual mode and switch out of the screen, you can hear the relays click. It automatically sets everything back to automatic mode, so there's no accidentally blowing up of preamps. Then the invisible hotspot to take me back to the splash page. Okay, enough of that. I'll get things going here again, and we'll get her transmitting. Okay, I've keyed it, and you hear the sequencer clicking in all the relays for the going from receive to transmit. The two current displays there for amp A and amp B are indicating the idling current, 200 to 300 milliamps. And then I'm keying it, so you'll see the current going up to 2 to 3 amps per side of the amplifier. I'll switch over to the first RF power output, and you'll see the needle go up and down. I'm varying the drive from the Kenwood, of course, and see how it fluctuates. It's pretty accurate at the top, right around 70 watts, but between 20 and 40, take that with a grain of salt. Then over to the other meter, which is using the amplifier current, shows right around 70 some odd watts. It's pretty accurate. It's a relative indication anyways, but it's still a pretty neat looking display. So I'll flip back to the main operating screen and see the currents going up and down right now between 3 to 4 amps each. And you can notice the temperature is slightly going up. It's a slow recording, that part of it. I didn't have it instantaneously like I usually do. It's just there for the fan, so it works. Anyways, all in all, that's kind of wild. So that's it for now. Another use for a PIC and a Nextion screen and a pile of junk put together. Get her going this summer. Get the two loop Yankees up there and see what I can do with this thing. It should be fun. Anyways, thanks for watching. 73s again from Skip, Victor Echo 6 Bravo, Golf Tango. Till the next time.